Hello, my fellow ARC AGI friends. In this tutorial, we're going to learn how to use a frontier language model and test it against the public training and public evaluation sets of ARC AGI. This means that you can put the ARC AGI benchmark to the test using GPT-4 and Claude 3.5 Sonnet. Now, in addition to working with those models, we're going to learn a little bit more about working with Kaggle notebooks, how to store secrets, and then how to run our tests against the full public training and public evaluation sets. Now, in the official ARC Prize competition, your notebook won't have access to the internet. That is so that we can ensure that the hidden private test set does not get leaked, because one of the key aspects about ARC AGI is that hidden test set remains hidden. If you want to see more about that, head over to arcprize.org to find out why. Regardless, in this tutorial, you will be able to submit your notebook to the ARC AGI public leaderboard. This means that we acknowledge that your model will have access to the internet. You're using frontier AI models. Now, while it's not eligible for prize money, we're still very, very curious to see what types of methods you can come up with in order to squeeze out more performance with these models. And here's the ARC AGI 2024 high score leaderboard. Up at the top, we have the scores that we see on Kaggle. So these are verified against the private evaluation set. Now, if you scroll down a little bit, you're going to get the ARC AGI Pub 2024 high scores. These are the high scores that these GPT-4 notebooks would be eligible for. Now, I encourage you to go to arcprize.org/leaderboard to go read more information about this. But if you'd like to submit a claim for a state-of-the-art solution towards the ARC AGI Pub dataset, you can go ahead and you can submit one on this Google form down below here. Let us know about it and we will be in contact with you. So without further ado, let's jump into some code and see how to use these notebooks. All right, here we go, using frontier models on ARC AGI via LangChain. Now, we're using LangChain for a few different reasons. One, because it's really easy to swap models. Two, because they help with output parsing. And three, because they make working with prompts a bit more clean. Now, if you're landing on this notebook for the first time, up here in the top right, I have an edit button, but you should see a copy and edit button, which just means that you're going to make a copy for yourself. Now, welcome to a Kaggle notebook. Here is basically like a Jupyter notebook, but this is going to be attached to a Kaggle instance. Now, the cool part is you're going to have different data inputs and a working directory that you can work with. So the first thing you're going to want to check out is to make sure that under competitions right here, you have the ARC Prize 2024 competition attached. This means that you're going to have certain data sets attached to your data as well. So we have the ARC AGI evaluations, challenges, solutions, et cetera, et cetera. We'll go through what these are in just a second here, but you want to make sure you have that. Now, under your output working directory, you should have nothing right now. Think of it as if you save any files or if your model outputs any files, they're going to be held underneath here. And we'll also get to that in just a second. Now, you'll see a submit button right here. Again, remember that you won't be able to submit these notebooks if they require internet. Now, in this case, I'll be using GPT-4, which does require internet, so I won't be able to submit it to the competition. However, you can submit it to the ARC AGI public leaderboard. And there's more information on arcprize.org/leaderboard if you want to go check that out. All right, so you can see here that I have internet on, which you want to make sure that you do. And let's just jump right into it. All right, so first thing we're going to do is let's look over our goal. So with these notebooks, the goal that you want to do is you want to create a submission.json file. Now, the reason why we're doing this is because this is how the official Kaggle competition scores its output, or your model's output right here. And it also makes it really easy to standardize on how we're going to score here. So instead of you creating a file with some random name that we won't be able to work with, we want to do a submission.json file. First thing we're going to do is we're going to install LangChain. We're going to install LangChain OpenAI, and we're going to install LangChain Anthropic as well. So you can see here that my session is starting. We're just going to wait for this to kick up right here. Great, now that these packages are installed, let's go down here, and this is going to be our import statements. And so we have a bunch right here, but the one I want to draw your attention to is going to be the user secrets client. So the way that Kaggle deals with environment variables is they want you to throw them in your user secrets client. So that's going to be underneath add-ons, and you're going to go to your secrets right here. And I have my OpenAI API key attached to my notebook, and you want to make sure that it's clicked attached right here. And you can go ahead and edit that if you want to. But either way, this is now going to be in my environment, and you're going to want to pay attention to this label because you're going to use this a little bit later. All right. So let's go ahead and let's first import all of our packages. Great, we imported those. Now what I want to do is I want to show you the files that are actually attached to our notebook here. So imagine you're running this on your local machine. You're going to have some certain files available to you. Well, we have some files available to us on the Kaggle notebook. Now here we have Kaggle input. So this means that we're going to use it for our input. And then ARC Prize 2024. This folder corresponds to the competitions folder that's up here. And you can see here that we have all the different files that correspond to these files on the right-hand side. Now let's go over these files very briefly. So in the ARC AGI data set, in the public data sets, there's two different types of tasks. There's training tasks And then there's evaluation tasks, right? So training tasks is what it sounds like. It's meant to be trained on. And then evaluation is a public way for you to evaluate your progress and how you're doing. So here we have the ARC AGI training solutions. This means that there's the answers to those tasks. Now, each one of the task set is going to be split up into challenges and solutions. So here we have the ARC AGI training challenges and the corresponding solutions folder. And then we have the same thing with evaluation challenges and evaluation solutions. All right. Now, if you wanted to see a sample submission.json, well, you can go check that out right there. So next thing I want to do is I want to create a very quick dictionary that holds the different file locations for the different types that we're doing. And this just makes it easier to swap out different tests later. Okay. So next thing we're going to do is we're going to create a very quick function that's just load tasks from file. And what I want it to do is I want it to return the challenges and solutions for me. All right. So what I want to do actually is let's go take a look at some of this data and let's see what we're actually working with. And so we're not just working in the abstract. So here I have challenges and solutions, and I'm going to load up the training data. So let's zoom in on this one challenge right here. This is task ID 0520FD37 or E7. All right. So I first want to draw your attention to the train pairs. So these train pairs are going to be a series of input and output pairs. This means you're going to see an input and then you're going to see some sort of skill program give you the output, right? But let's go ahead and let's take a look at this task in visual form because it's easier for us to talk about this. We can go to arcprize.org/play and then type in your task ID. So now that we have this task ID, we can zoom in here and we can see we have one input pair, two input pair, three input pair. So input, output, etc. And then in our test, we only have one input and one output corresponding, right? So these three input pairs are going to correspond to those other pairs that we saw. And then this one test input is going to be the JSON that represents this grid right here. So you can see here that we have a 7x3 and we have a 7 row by 3 right here, which is what it corresponds to. Now, this is the challenges side. So your model's going to have something to train on, and then it's going to get a single test input. Now, your goal is going to be to produce an output for that test pair, and that output is going to get matched up against the solution, the ground truth solutions, and we're going to see whether or not you're right or wrong. All right, so let's keep on rolling down here. Well, now that we have our data, it's just time to set up our language model. So here I'm going to use GPT-4o. And even though I'm using GPT-4o, this is all going to be text-based. I'm not going to use any multimodal functionality here. But I encourage you to try this out too. And that's an easy way for you to do some prompt engineering or for some different methods to see how you do. Now, notice that my OpenAI API key is going to be user secrets client get secret. And this is the same label that I had up above. Now, I threw Claude in here in case you wanted to go try that. Completely up to you. You go for it. Okay, so we'll run that. And then let's go down here. Now, the next thing we need to do is we need to convert our JSON task that we have, which is going to be the train, all this stuff. Well, the language model doesn't do very well with just raw JSON like that. Like I want to be able to do a little bit of prompt engineering so I can explain to it, hey, this is example 1, example 2, example 3, or whatever. And so here I'm creating another function called JSON task to string. And I won't go through all of this, but suffice it to say that I'm basically doing some really hacky text combining and for loops and everything to get ourselves a JSON or a string from our JSON example. So if I wanted to look at that same example that I had up above, let me go ahead and run this. And here we now have a piece of text, and this is what will go into our prompt so we can instruct GPT-4 on what the heck this problem is about, right? So training examples, we have example 1 input, example 1 output, example 1, 2 input, and output. Now you may be saying, hey Greg, that looks pretty sloppy. Why would I do that? Well, this is a hello world example. So I highly encourage you to use this as another optimization point for you to go have some fun and see if you can do a better job at instructing GPT-4 on how to use these tasks. Maybe you don't want to use ints. Maybe you want to use letters instead. It is a language model, probably does better with text. Maybe you want to use symbols. Maybe you want to use emojis. I don't know what you want to use, but you should go figure it out and have some fun with it. All right. So now that we have our JSON text that we have here, now we also need to take care of just a little bit of output parsing. Now, the reason why we need to do this is because we need JSON back in order to go see whether or not we're right or wrong, because our solutions are finally going to be in JSON. So Well, when we do that, language models aren't great at outputting JSON. And rather than screaming profanities at the language model and begging it with $200 to try to give us valid JSON, I'm going to use LangChain's output parsing. Now, it's not perfect, but it is going to get us to 85% of where we need to go. And then if you add a couple retries on top of that, we're going to get mostly the other way there. So first thing I'm going to do is I'm going to define my Pydantic class about what I want it to be. And here, I just want a simple prediction. So it's a one field output, and it's going to be a list of lists. And the reason why we have a list of lists is because if we look at our outputs right here, well, it's lists of lists. And so we have what we need right there. All right. Well, so cool. Now that we have that, what we're going to want to do is finally make our language model prediction. So we've done all this work just to get set up for this one moment right here. All right. So I've created another function that is called getTaskPrediction. So we're going to pass it our challenge tasks. We're going to pass it the task ID of the one specifically we want to work with. I won't go through all of this because you can go check it out yourself. But the important part is here is the beginning of our prompt. Now, again, you may be wondering, Greg, this looks really sloppy. It doesn't really look like you're doing much here. I highly encourage you to go do some more prompt engineering and see if you can improve upon this pattern right here, right? So you are a bot that is very good at solving puzzles. Below is a list of input and output pairs with a pattern. Identify the pattern, then apply that pattern to the test input and give a final output. Just give a valid list of lists, JSON back, nothing else. Do not explain yourself. And then also this is a little bit of a LangChain artifact, but it's going to pass in some format instructions. And then I'm going to give it the task string that we made earlier. Remember when we turned the JSON task into a valid string here? So that's going to go right there. All right. So, and then we're going to make our LangChain chain. And this is using LangChain expression language, which is where you see these pipe operators here. We're going to pass it our prompt. We're going to pass it our language model, which is GPT4, and then we're going to pass it our parser, which is the JSON output parser that we had beforehand. All right, and then we'll do some error handling right here too, just in case it's not a valid list of lists afterwards. I want to raise an error because we're going to do some retries. All right, so let's go ahead and run through that. And then what we're finally going to do is we're going to go ahead and create a master function that's going to run our model. So we're going to pass it our challenges. Then we're going to pass in the number of attempts. Now, another unique artifact of the ARC AGI challenge is you actually get 2 tries per test task that you're trying to do. Old competitions had 3, and in ARC Prize 2024, you get 2 tries. Now, this is 2 tries that you give in parallel. You give at the same time. They're not sequential tries. So we call these attempts. What you'll do is you'll say, hey, for this challenge that we have here, here are my 2 guesses as to what I think the answer is, right? And then we'll go and check those 2 attempts and see whether or not one of them is right. If one of them is right, you get full score for that task. If 2 of them are right, you get full score. If none of them are right, then you don't get anything. All right. And then for retries attempts, this is just me going to be retrying and going back in case there isn't valid JSON that comes out the other end or a timeout error or something like that. Right. I won't go through this entire thing, but you can go check out the function on your own. But basically, just suffice it to say, we're going to run through the challenges and go get some answers, go get some predictions. All right. So what I want to do here is I want to show you an example of this running just on one task. So I'm first going to load up my challenges and solutions using our load tasks from file. And then I'm going to set the task set to our training sets. So this is the easy stuff that we're going to get. Now, I should have mentioned that there are 400 training tasks and there's 400 evaluation tasks. So you have plenty of data to work with to go have some fun on. And then we're going to run the model on the challenges, which we load up right here. And the number of tasks we're going to do is just 1 because we're just testing right here. Then let's go see our submission. So starting task number 1, this is the task that it's doing. Pair 1, meaning this is the first input pair that it's trying. Prediction attempt number 1. Retry number 1. And then because this prediction grid size, it actually gave a valid output. No retries are necessary. This looks good. So here we are with our final submission that we have. For this task ID, here is our submission attempt. Now what's cool is you can see here's attempt number 1 and here's attempt number 2. Now, one thing I didn't do within my prompt engineering is I'm not letting the language model know what its attempt number 1 was before it makes its attempt number 2. So they actually could be the same things. That is not very optimized, but I encourage you to optimize that as well if you want to go even further on that. So let's check out which task this is. So again, I'm going to go to arcprize.org and I'm going to go play, and then I'm going to look at the task ID and I'm just going to insert that task. So this is the task that we're working with. And you can see here that the output looks like it's going to be actually quite large. So it looks like a 9 by 9. And if we go back to our prediction, you can see here that both predictions are 9 by 9, which is a good thing. This means that the model is able to determine how big the grid size should be. The reason why I say that is because the grid size is not always the same as your input size, especially as you can see right here. Here's a 3x3 input and you get a 9x9 output. All right, great. So that's one input attempt, but well, what about the other 400? Or what about however many we want to do? Well, let's go through the rest of them and go figure out what our predictions are so we can go and score them. Now, remember what I said about the submission.json file. This is the really important part because this is how you're going to evaluate your output. So we're going to create another function that is create submission file, and the file name we're going to give it is submission.json. And so here we're going to give it our submission, which is basically going to be a list of dictionaries that have all of these. And this is the task ID is the key, so we know which one we're working with here. All right, so let's go ahead and create that. And then the last thing we need to do is we just need to score our submission. So we're going to go to score submission right here, and we're going to create a function that is going to go through with a bunch of for loops to figure out what is the final score that we actually get. Now, I will say I've done a second notebook all around ARC prize scoring. So if you want to go check out much more detail and tactically how ARC prize is scored, you can go down here and see the scoring methodology, that output file, and go through the exact code that does this. I'll put a link over there. Cool, now that we have our scoring, we have our language model, we have our data, we have everything, now it's time to bring it all together. So here's gonna be my main function that's gonna run the entire thing. So what we're gonna do is we're gonna load up our challenges and solutions via the load task from file, and then we're gonna run the model. So we're gonna run the model on our challenges, and the number of tasks is gonna be the num tasks that you have right here. Now, if num tasks is none, it's gonna run against the entire thing. Just be careful and mindful before you do this. Then what we're gonna do is we're gonna create a submission file with our submission, and we're gonna give it our file name, submission right here. And then we're going to score the results. So we're actually going to score our submission, see actually how we did. And we have our submission file name and our solutions. And then we're going to print out the final score and see what we got here. So let's go ahead and run this. I want to run main right here, and the task set I want to do is the evaluation task set. So that's those 400 public tasks in the evaluation folder. Now the number of tasks I want to do is 2. So let's go ahead and run this right here. All right, so we have our first task, pair number 1, retry 6x6, not too bad, 6x6. Okay, cool. We have our 2 attempts for task number 1. Now task number 2 is running a little bit slower here. I bet it's a little bit bigger. Yep, here we go. So attempt number 1, retry 1. Error, the output must be a list of integers. And so this is where we put our retry in. We're going to retry one more time. Here we are, retry number 2, and we got a valid 14 by 14 out the other end, which is good. Attempt number 2, retry number 1. Let's see what we got here. That looks good. And then we saved our submission to submission.json. We loaded it up. We're going to score it. Now we're scoring task right here, scoring task right here. And attempt number 1 matches the solution. Task number 1 matches the solution. Task number 2 matches the solution. So in this case, we were able to get 2 out of 2 for our public evaluation first 2 tasks. Now, I've done this a bunch, and 2 out of 2 is actually kind of rare. I've actually never seen that happen. It's usually 0, 0.5, or 1. But that's a cool example because I wonder how many more you could get right if you were to do some prompt management out the other end. I bet you could do a whole lot more. So awesome. Congratulations. You just did your first submissions with GPT-4o against the ARC AGI dataset. Now, keep in mind that these are the public evaluation tasks. So there might be some data contamination here because when GPT-4 was trained, who's to know whether or not they found the ARC AGI dataset, the public ones at least, and put it into its training data. So while this isn't very indicative of how it would do on the private evaluation set, this still allows us to start to benchmark the performance against the public datasets. Now, again, this won't be valid for the official ARC Prize 2024 prize award because it's using internet access, but it's a really good start for us. All right. Now, what I want to do here is I would love to see how you would do with Claude 3.5 Sonnet, with Gemini. Who knows? Maybe you need 2 million tokens worth of context in order to get what you need out of this. I would love to hear how you do. So please let me know on Twitter. Please let me know and email us at team@arcprize.org. Let us know on Discord. Let us know wherever you want. And I'm excited to see how you do. So keep me in the loop, and we will see you later. Happy testing and happy ARC Prize. We'll see you later.